Hi dear students, hope you are all doing good. So welcome to today's Brainiacs Capsule. So we are going to conduct the fourth important session based on the concept nucleophilic addition reaction. But here there is one difference. We know that in nucleophilic addition reaction there are two things. One is in certain reactions nucleophilic addition alone will happen. In certain other reactions we know nucleophilic addition followed by elimination will also happen. This also we are learning in our NCERT text. So today we will focus questions more based on nucleophilic addition followed by elimination. Okay. So let's see the first question. So the first question here is, which does not react with the sodium bisulfite? Very important reaction. So it is also given in the NCERT text. Okay, but they have given a very single clue. Okay, with that they have created a question. That's the importance of this. So you are given four options. Okay, so you can notice one thing, in out of these four options only one compound is ketone, everything is an aldehyde. That itself is a clue, and I can easily say option 3 would be my correct answer because it is a ketone. Please understand, in a ketone the steric inhibition is very high, and because of that the nucleophile finds it very difficult, especially the nucleophile used in this particular reaction is HSO3 minus, which is a bulky nucleophile which find it very difficult to go near to the vacant orbitals of carbon and attack it. So the answer here is option 3, but I can explain you in detail. Listen here. So NaHSO3 is called sodium bisulfite. Okay, and this on ionization will give you Na plus and HSO3 minus. Okay, so this is a bulky nucleophile, you can see here. And please remember, in the options you are given an aromatic ketone like this. So I can easily say this will not react with this. Why? Because when it is undergoing polarization, a plus charge will come here. But because of the two benzene ring that is present here, the bulky nucleophile will experience a huge amount of repulsion, because the benzene itself have 3 pi bond, another here have another 3 pi bond. So 6 pi electrons will repel the incoming nucleophile, which is also negative charge. So please remember, steric repulsion is preventing the nucleophile from attacking this one. Okay, so the aldehydes react with, usually what is the case of aldehydes then? I can easily say aldehydes will react with NaHSO3. Why? Because in an aldehyde you can see always one carbon is connected to a hydrogen, which is a very lightweight element, and there is no repulsion the nucleophile will face, and that is one reason we say aldehydes are generally more reactive than ketones. Okay, now I can say my answer here is which one, sir? So already I have explained you the concept. So the answer in this question here is option 3 is my correct answer. I hope you understood the concept. Understanding the concept is very important. Okay, now let's switch to the next important question. Very big question. Okay, reaction of a carbonyl compound. Listen, reaction of a carbonyl compound with one of the following reagents. It involves nucleophilic addition followed by elimination of water. The reagent is. So I told you, in carbonyl compounds, aldehydes and ketones, they give generally nucleophilic addition reaction. But this depends upon the reagents. With some reagents it give only nucleophilic addition reaction. But with certain reagents it will give you nucleophilic addition followed by elimination. So they are asking you, out of the 4 reagents, who is that? Okay, so let's see one by one, and I will explain you in detail how carbonyl compounds react with hydrocyanic acid, that is HCN. Okay, I will also explain how it will react with, just now we have seen NaHSO3, that is sodium bisulfite, and also with the Grignard reagent. And also I will explain finally with the hydrazine what would be the expected product and what is the mechanism. Okay, it's very important question. Let's see. So the first one, you can see with HCN how it is going to react. Again, I know the concept is HCN will undergo heterolytic fission. You will get H plus and Cn minus. And we know for aldehyde and ketone it is always like this. The carbonyl group will undergo what? Polarization first. So you will get a negative charge here and a positive charge here. We know that the octet of oxygen is complete here. You have a vacant orbital of carbon here. So the first attack comes from the nucleophile to the positive charged carbon. Okay, so you will get a species like this, a tetrahedral intermediate. And this O minus will be further attacked by whom? The H plus from the HCN, and you will get a compound like this. I can easily say the reaction stops here, and here the peculiarity you can see, it's a chiral carbon because the 4 groups present here are different ones, and I can say this is an optically active compound. Okay, so usually in exam they may ask one more question: what will happen to this particular product if you add water? So please understand, out if you are adding water to this one, CH3 will not undergo any change, hydrogen will have no reaction, OH also will not change, the cyanide will undergo hydrolysis. So please remember, cyanide will undergo hydrolysis in such a way that if you add one molecule of water, this will become CONH2. Very easy, you simply add H2O to Cn. So what it will become, one oxygen going here, CO, then N, two hydrogens are here, you are getting CONH2. Now the thing is, if you are adding one more molecule of water to this amide, this is an amide, if you are adding one more molecule of water, this will become carboxylic acid. Why? Because NH2 is a nucleophile that would be replaced by OH minus of the water. So you will get COOH. So here I am assuming excess amount of water is added. So you will get carboxylic acid. So this is an important conversion they can ask in the exam. So here also you can see what is the mechanism, sir? Just nucleophilic addition. Correct? It is not elimination of water. It's not happening here. Now let's see the next type of reaction, that is reacting with the sodium bisulfite. Please remember, it is a reversible reaction. Okay. Now this will undergo again ionization to create Na plus and HSO3 minus. Please understand, this is the structure of HSO3 minus. You can see it is a bulky nucleophile, and moreover you can see this may be stabilized. You can see lone pair is present. Okay, so this is a bulky nucleophile. So what will happen? This negative charge will move towards the positive charge, and just now we have learned that this nucleophile will not react with a ketone because of the steric repulsion. Okay, so here it is an aldehyde, so it will come and attack the positively charged carbon. So you will get something like this initially, a tetrahedral intermediate. Again the concept mechanism remains the same. Again Na plus will come and attack the O minus, and you will get a compound like this. But one difference is there. What is that one difference? Here SO3H is a sulfonic acid, and this is a metal. We know that acids react with metal to liberate hydrogen. So I can easily say this acid will easily liberate H plus. Why? Because this is acidic in nature. It can easily liberate H plus, so that the remaining structure SO3 minus is stabilized by resonance. This H plus will easily replace sodium. We have learned in 8th standard that whenever you have a metal is there, when it reacts with hydrogen, it will easily liberate that metal. Correct. So what will happen? H plus will come and attack the O minus, and OH will come here, and the liberated Na plus, what it will do? It will come and attack the SO3 minus. So you will get SO3Na, and this process is called a proton exchange. Just it is mentioned like a proton exchange in your textbook. Okay. So please remember, the product here is again fundamentally I can say it's an alcohol, not a sulfonic acid. That's very, very important, because the proton exchange occur and the final product is like this. Now I have repeated this the same lines I have taken from your NCERT. As the steric inhibition increases, the reaction with sodium bisulfite decreases. And we know that this is a reversible reaction, and the steric inhibition shifts the equilibrium towards the reactants. So that's why whenever acetone is taken, because it's a reversible reaction, the reactant will not undergo reaction, or it will not proceed forward. And that is the reason why we say ketones will find it difficult to react with sodium bisulfite. It is the lines given in NCERT, and from that we have seen already a question. Understood? Now we see the third. So here also what is the mechanism, sir? We can say nucleophile come and adding, after the reaction the double bonded carbonyl group is changing to what? Single bonded compound. You can see here. So again this is a mechanism, nucleophilic addition reaction. Why it is nucleophilic? First nucleophile come and attacking. Why it is addition? Because double bonded compound is changing to single bonded compound. Okay. Now the third option, reaction with the Grignard reagent, very, very important. So here with the Grignard reagent, it's a method of preparation of alcohols. So if you take different types of aldehydes and ketones, you will get different types of alcohol. So you can expect this question even for NEET exam this year. So I am first taking formaldehyde. and I am going to react it with a Grignard reagent like methyl magnesium bromide or RMGX. Okay. Now how the reaction will happen? Easily, again here also nucleophilic addition, first it will undergo polarization with the positive charge and negative charge coming here. And here what will happen? This will undergo heterolytic fission. We know magnesium is an electropositive element. It will repel the electron towards the carbon atom. So you will get the CH3 minus, which is a nucleophile, and that will come and attack the positively charged carbon first. So you will get again a tetrahedral intermediate. Then who will come and attack? The MgBr plus will come and attack the oxygen with the negative charge. So this is my nucleophilic addition product. But please understand, you are not getting an alcohol after nucleophilic addition reaction. Now you need to, what you need to do, you need to hydrolyze it with water. When you are hydrolyzing with water, what will happen? The magnesium being more electropositive, it will get attracted towards OH minus, which is a strong nucleophile, and you will get MgOHBr. Again, oxygen with a negative charge will come, that will be attracted by H plus, and you will get a primary alcohol. Why it is called a primary alcohol? Listen, the OH group is connected to a carbon, and that carbon is connected to only one carbon atom. So that's why we say this is primary alcohol. Okay, so I can conclude stating that, what is my conclusion, sir? Whenever formaldehyde is taken, whenever formaldehyde is taken, and this is treated with Grignard reagent, any Grignard reagent, RMGX, or even a benzene ring with MGX, whatever be the reason, you will get a product, nucleophilic addition product, and this on hydrolyzing, this is also a normal conversion. On hydrolyzing, you will always get a 1 degree alcohol. Very, very important. Okay, now we'll take, other than formaldehyde, if you take any other aldehyde, it can be, now I have taken acetaldehyde, you can take any other aldehyde. Let's see what is the reaction. So the difference you can just analyze here, to the carbon, one more carbon is coming. So the type of alcohol you may getting here will be secondary alcohol, no other difference. So what will happen? Here the bond will break. You will get the nucleophile CH3 minus. Again, this will undergo polarization. You will get plus and negative here. So what will happen? CH3 minus will come and attack the positive charge. You will get again a tetrahedral intermediate. And this will be attacked by MgBr plus. So you will get the first nucleophilic addition product. And we know that this on hydrolysis, what will happen? Mg will get attracted towards the OH minus, and you will get an alcohol. That is, you can see OH group is connected to a carbon that is connected to two other carbon atoms. So I can say this is a 2 degree alcohol. So what is my conclusion, sir? Conclusion is any aldehyde, okay, other than whom? Other than HCHO or formaldehyde. Okay, other than, I can say formaldehyde. 1 minute, I will put it neatly. Other than formaldehyde reacts with a Grignard reagent RMGX or even with benzene ring MGX, will give you a product, which on hydrolysis will give you what? Will give you a 2 degree alcohol. I hope it is clear for you. Okay, so let's go to the last one, that is how ketones will react. So ketones, now you can easily say, sir, in ketone there are 2 carbons connected to carbonyl group, so surely we will get a tertiary alcohol. Let's see the fundamental again, the same thing. Grignard reagent will undergo heterolytic fission, negative charge will come to the carbon, you will get something like this. And again we know the carbonyl group will undergo polarization, plus and minus will come here. The nucleophile will come and attack first the carbon atom because the octet of oxygen is already complete here. Next, what will happen? To remove the negative charge, to make the compound more stable, what will happen? The MgBr, or there is an ionic interaction between these two. So MgBr plus will come and attack the negative charge, and you will get the nucleophilic addition product. And again we know that this on hydrolysis, what will happen? MgBr will attracted towards OH minus first, so you will get a tertiary alcohol. So the carbon is connected to 3 other carbon atoms. So what is my conclusion? That is very important. Formaldehyde, if you are treating with a Grignard reagent, treated with water, will give you 1 degree alcohol. Any aldehyde other than formaldehyde, if you are treating with Grignard reagent followed by hydrolysis, will give you a 2 degree alcohol. Any ketone, whatever be the ketone, you treat with Grignard reagent followed by hydrolysis will give you a 3 degree alcohol. I hope it's clear for you. Okay. Now we will see the fourth one. So the fourth one is reaction with hydrazine. So before I go to that, let me explain you what is the fundamental concept behind nucleophilic addition, then followed by elimination. What is happening there? Let's try to explain that, and we'll show you what are the reagents that will give you this particular reaction. Okay. So I can fundamentally say ammonia and its derivatives. Ammonia means, you know, that NH3, and its derivatives means in ammonia you can see 3 hydrogens are present. Suppose each of these hydrogen, if one hydrogen is replaced by any other group, those are called derivatives of ammonia. All those compounds will behave like nucleophile when it is treated with aldehydes or ketones, and these guys will undergo nucleophilic addition followed by elimination. Why? Many students may ask a doubt, sir, why it undergo nucleophilic addition reaction alone? Why it is going for a elimination? The reason for that is the whole reaction is a reversible reaction. This is directly mentioned in your NCERT. Okay, and the equilibrium will proceed to right side for the formation of the product only if this removes water, then only it will end up in a stable product. That is the reason why it will always eliminate water. Okay, so it favors product formation only by dehydration. So let's see. So it's very simple. So what you need to see, if ammonia or its derivatives are given in a reaction, if it react with aldehyde or a ketone, surely the mechanism would be what? First the nucleophilic addition product you will get, then followed by removal of water like this, H2O. Then you will get a product, double bonded product like this. Water is eliminated. So very simple. Now from the options you can find the answer. Why? Because ammonia and its derivatives means from the option I can say only one is present, that is hydrazine. Why it is called an ammonia derivative? Because hydrazine is what? Hydrazine is NH2 single bond NH2. This is my hydrazine. Why it is called an ammonia derivative? Because in ammonia we can see there are 3 hydrogen atoms are present. If one of the hydrogen atom I am removing, okay, and adding an NH2 group there, then what you are getting? One of the hydrogen atom is removed, so you can say here NH2 single bond, one hydrogen is replaced with NH2 group, so you are getting hydrazine. So that is the reason why I am saying hydrazine is an ammonia derivative. So surely hydrazine will undergo nucleophilic addition followed by elimination of water. Now I will help you how this mechanism happens, and I will explain you in detail what are the other reagents and what are the products you get during this particular process. It's very, very important. Directly I have taken from NCERT who are the reagents which undergo like this. Okay, so we can say first reagent, I am taking now our ammonia like this. You can see here ammonia and its derivative is represented as how? Listen. It is represented as NH2Z. NH2 ammonia, and its derivative means hydrogen is replaced by anybody. So Z can be alkyl group, aryl group, OH group, NH2 group, C6H5NH group, anything. So let's say if Z is equal to a hydrogen, then I can say what is this guy? Hydrogen coming means it will become ammonia. In that case, aldehydes and ketones react with that to form a product that is called imine. I will explain you the mechanism, don't worry. Now I am going to replace this Z again with an alkyl group. Now the product or that particular reagent will become what? If Z is removed with the alkyl group, it will become an amine. It will become an amine. So amines react with aldehydes or ketone to form a product that is called substituted imine. This substituted imine is called Schiff's base. It's a very important question for this year's NEET. Okay, the question can be Schiff's base will be produced when aldehydes or ketones react with whom? They may give option like ammonia, hydroxylamine, hydrazine, then amine. So the answer here would be amine. Okay. Next thing is, now the Z is replaced with OH. Then that is called hydroxylamine. Why? Because NH2 is already there and hydroxyl group is introduced. Then in that case, my product is called oxines. Okay, whenever I am going to say here the Z is replaced by another amino group, that's what we have seen here, then that will become hydrazine. The product is called hydrazone. And what happens if that in that hydrazine 1H is replaced by a phenyl group, then we will call that as a phenyl hydrazine. Then the product is called as a phenyl hydrazone. So please remember, any of these can come for exam. Now I am putting 2 nitro group into that phenyl group. Then we call that reagent as 2,4-dinitrophenyl hydrazine. Then the product is called 2,4-dinitrophenyl hydrazone. But the mechanism remains 1-to-1 same. Okay, the last one we call that as a semi-carbazide, when one of the hydrogen is replaced by an amide group. Okay, so in that I am again telling with respect to hydrazine. In hydrazine 1H is replaced with CONH2. Then that is called semi-carbazide and the product we obtain would be called semi-carbazone. Okay, now we will take one by one. Now you may know that it may be little bit lengthy, but those students who doesn't know this, please listen to this. The mechanism, once you see it, you may understand nothing new to learn. Only do the same thing for every reagent. Okay. So again, the concept is, first I am reacting with ammonia. What is the first thing? Generate the nucleophile. Whenever you want to react with aldehyde or ketone, first thing is generating the nucleophile. So how to generate a nucleophile? Remove the H plus. The remaining thing is NH2 minus, which is a very strong nucleophile. Okay. Now what will happen? Here, first thing is, again the carbonyl group will undergo polarization to generate plus and minus. So who will come and attack first? Octet of oxygen is complete here. So the nucleophile NH2 minus will come and attack the positively charged carbon. So again you will get similar tetrahedral intermediate. Then the H plus already generated here will come and attack. So you are getting something like this. So I can say this is my nucleophilic addition product, but the problem here is this is a reversible reaction. It will not stop here. So what will happen? The thing what here going to happen here is the NH2 that is present here will liberate an H plus. So what it will get? It will become NH minus. And many students will ask, sir, why it do like this? The reason for that is nitrogen is an electronegative element. If a negative charge comes to an electronegative element, it will become stable. That is the reason why it is able to liberate this H plus. So what this H plus will do? This H plus will come and attack the OH here. And what will happen? The oxygen will get positive charge, and we can easily say oxygen with the positive charge is highly unstable, and these 2 electrons will move towards the oxygen, and because of that a heterolytic fission will happen here and a positive charge comes here. And now I can say this is stabilized by resonance. That's why this is moving forward like this. And what will happen? Negative charge, single bond, positive charge. I can easily say the negative charge will move towards the positive charge and a double bond will be created. And this is my product. We can easily say carbon double bond nitrogen, and this product is called imine. Understood? Very simple. The same thing we are going to do with the next one, with the primary amine. So primary amine, what is the difference? In ammonia, one of the hydrogen is replaced with an alkyl group R. So you are getting a primary amine. Sometimes in the question, instead of R, they may give CH3NH2. Again, the mechanism will remain the same. So again, what you need to do? Remove the H plus from the nitrogen. Don't remove the H plus from the alkyl group. Why? Because when H plus is removed, a negative charge will come. Negative charge will get stabilized if it moves to an electronegative element. Carbon is not an electronegative element. Nitrogen is an electronegative element. That is the reason why from here hydrogen is removed. And you are getting the nucleophile RNH minus and H plus. So again, this will undergo polarization like this, and here the nucleophile will come and attack the positively charged carbon. Okay, like in the previous reaction. Again, you will get a tetrahedral intermediate. Now, this will be attacked by the H plus. You are getting your nucleophilic addition product. But the reason again I am telling, you are having here also you can see nitrogen with nitrogen is associated with a hydrogen. I can easily say this hydrogen would be acidic. Why? Because if it moves out, a negative charge comes to the nitrogen atom. Negative charge near the nitrogen atom is stable. So I can say it will remove the H plus, and this hydrogen only will attack this OH minus OH, and what you will get again the same mechanism. Oxygen will get positive charge. This pair of electron will move towards the oxygen atom. Here heterolytic fission will happen. This will move as water and a positive charge come to the carbon atom. Now I can easily say negative charge single bond positive charge. It is stabilized by resonance. So negative charge will move towards the positive charge. Again you are getting a double bond. No difference, only from the previous reaction hydrogen is replaced with R, nothing else changed. So this is called hydrogen is replaced with R, so we call this as a substituted imine, because here also carbon double bond nitrogen is there, so that is an imine, but instead of hydrogen an alkyl group is coming, so we call this as a substituted imine, and that is called Schiff's base. Very important, Schiff's base. They can ask in the question, what is Schiff's base? Imine, substituted imine, amine, substituted amine, like that they can ask. Okay. Now again we will do the reaction hydroxylamine. Again you will have NH2OH. What you need to do? Again very simple, hydrogen will be removed from nitrogen because you have more number of hydrogen connected to the nitrogen. Okay, and I can say the electronegativity of nitrogen is less compared to the oxygen. Okay, so I can easily say from here hydrogen would be liberated H plus, or you can remember like this, in all these reactions H plus will be removed from nitrogen only. Okay, so what you will get, NH minus OH. So this is a nucleophile, so this will come and attack the positively charged carbon. Okay, so again you will get a tetrahedral intermediate. This is further attacked by H plus. You will get a nucleophilic addition product, but the reaction will not stop here. What will happen? Again there is a hydrogen present here. We know that hydrogen connected to nitrogen is acidic, so this will move out as H plus, and that will attack the OH. You can see here. So again what will happen? Oxygen will acquire positive charge. Heating, water would be removed, so you will get a positive charge here. Again negative charge, single bond positive charge, stabilized by resonance. So because to create this resonating structure, I can easily say the hydrogen is liberated from nitrogen, and because of that negative charge will move towards here, and you will get again C double bond NOH, and whenever OH group is connected to nitrogen along with the C double bond N, they are called oximes. And oximes will show geometrical isomerism. Okay, C double bond NOH is present, then it is called an oxime. Okay, so please remember with the hydroxylamine you will get a product that is called oximes. Now let's see in our question hydrazine, how it will react. Again this is a symmetrical compound, you can remove hydrogen from any of the nitrogen, it will not change, there is no meaning. So H plus is removed from, let me say, from this nitrogen, so you are getting again the nucleophile like this. Again this nucleophile will attack the positively charged carbon. Again you are getting the tetrahedral intermediate. Again the H plus will come and attack the O minus, so you are getting your nucleophilic addition product. Again the same thing, there is a hydrogen present in the nitrogen, so this will move out as H plus, and this H plus will attack the OH, and what you can say, easily oxygen with the positive charge will come. This pair of electrons will move towards the oxygen, the bond will break, positive charge comes, this is stabilized by resonance again. Okay, then again what will happen, the negative charge will move towards the positive charge, and you are getting C double bond with the NH2. Earlier OH came, now NH2 came, and this is called hydrazone. Okay, so if hydrazine is taken, you are getting hydrazone. Understood? So I am hoping you are understanding the mechanism is remaining the same. Nucleophilic addition, then followed by elimination of water molecule. Okay, that is why these type of reactions are called nucleophilic addition followed by elimination. You can easily remember it like ammonia or its derivatives will only give nucleophilic addition followed by elimination of water. Okay, now next one, phenyl hydrazine. What is the difference? In one of the hydrogen is replaced by a phenyl group, then that is called phenyl hydrazine, because from hydrazine one of the hydrogen is replaced by a phenyl group. Again what you need to do, remove the hydrogen from this nitrogen, generate the nucleophile like this, okay, attack on the positively charged carbon. So you get a compound like this. Again you can see H plus will come and attack here. You are getting nucleophilic addition product. Nothing is changing. Then again what will happen? This nitrogen again associated with hydrogen, it will remove H plus. This H plus will come and attack OH, and I can easily say this will remove water, and you are getting a stable intermediate. That is the reason why from this nitrogen hydrogen is liberated. Okay, now I can easily say negative charge, single bond, positive charge. Negative charge will move towards the positive charge. Conjugation is present. You are getting, this is called phenyl hydrazone. Hydrazone was the product. Now phenyl group is also present. We call it as phenyl hydrazone. That's it. Now nothing changes. Only thing is I am introducing nitro group here and here. Then I can say the same mechanism. Nothing else. From here again hydrogen moving out as H plus. You are getting this as the bulky nucleophile, very bulky nucleophile. This will come and attack here. Again the same mechanism. Removal of water. You are getting 2,4-dinitro. You can see here, those who are taking a snapshot can take it out. You can take a snapshot if you want to learn this as a note. Okay. So you are again getting a 2,4-dinitro phenyl hydrazone. That's it. Now the last one, what is the difference, sir? From the hydrazine, one H is replaced with a C amide group. That is called my semi-carbazide. Semi-carbazide is what? NH2, NHCO, NH2. Now again from this one, H plus is liberated, NH minus is coming. So again this is a very bulky nucleophile. This will come and attack the positively charged carbon. Okay, so you will get a tetrahedral intermediate like this. Again H plus will come and attack the negative charge. So you will get a product like this, nucleophilic addition product. Again the same mechanism. The hydrogen from here is acidic. It will move out as H plus. Okay, then what will happen? The H plus will come and attack the OH. Then oxygen with the positive charge is unstable. So this pair of electrons will move here and it will be removed as water. So positive charge comes, single bond, negative charge. I can easily say this is also stabilized by resonance. So I can easily say this negative charge will move towards the positive charge and you will get a product, and that is called a semi-carbazone. CH3, CH double bond, NNHCO, NH2. That is my product. Now let's see in our options whether this is present or not. All of you, how is it? Okay, we went through all the reactions, right? Okay, let's see. So in my product, I can easily say in this particular question, my answer would be which one? Which of the following reaction? With the HCN, I know the reaction would be NAR, nucleophilic addition reaction. With the sodium hydrogen sulfate, the mechanism is NAR. And with the Grignard reagent also, it is NAR. Okay, but with the hydrazine, the mechanism is NAR followed by elimination of water. So the answer would be option 4. I hope you understood. So if you have liked our explanation, please consider subscribing the channel. And if you need a crash course or anything, you can directly approach Brainiacs Classes, which is one of the leading coaching center, Neet coaching center in Coimbatore. Thank you.